Hello dear friends, my name is Sanjay Khan. I have been teaching for IIT JEE and NEET for last 15 years. Today we are going to discuss a very simple concept, pulley block system. Right? Suppose I have a system here. Generally this system consists of one very light pulley. That light means the mass of the pulley can be ignorable. Right? And the strings are inextensible and the strings are light and nowhere is friction involved. Right? This system generally is known as Atwood machine. Professor Atwood once used this method to find acceleration due to gravity. That's why this is known as Atwood machine. Now, suppose this is the question. I want to find acceleration of each block. Suppose this block is little heavier and suppose this is little light. Let us suppose a very fat man is hanging from this side and very thin man who is underweight. That person is hanging from this side. Obviously, this man will go down, this man will go up, right? So this is the system. I want to find acceleration of the system. So as the string is inextensible, we have assumed, that means what? Whatever the distance the block has travelled, the same distance this block also has to travel. Otherwise, the string won't be inextensible. So the acceleration, the magnitude of the acceleration of this block, suppose A, so this block also must have the same acceleration. Otherwise, the string won't be inextensible. So this is the problem. Suppose I want to go conventionally to find the acceleration of each block and tension suppose. So initially, let's try the different ways to approach this problem. So initially, let's try this problem in very conventional method. So what conventional method? So to describe the motion of each block, we have to apply Newton's law of motion, right? So what are the different forces acting on this? One is the tension, and another one is what? Gravitational force. Suppose the gravitational force is acting on m1g, on this block is m1g, and on this block m2g. As the gravitational force always acts downward. Okay. So this block is going upward and this block is going downward. If I write the equations for these two, what should be the equations for these two? This should be as it is going down. This force must be greater than the tension. So resultant force is acting downward, and we know according to second law of Newton's, net force acting on the block must be equal to mass into acceleration. What is the m2g? Different forces are acting on this m2g and tension. m2g minus t should be equal to mass of the block into acceleration. And suppose here this block is going up, that means this tension must be greater than this m1g, right? So tension, the equation of this block is for tension minus m1g. Resultant force should be equal to mass of the block into acceleration. If I solve this, similarly minus t plus t get cancels, and if we solve for a, the acceleration will be what? m2g minus m1g. That will be m2 minus m1 into g by m1 plus m2. Right? This is the acceleration. And if I put this value of the acceleration either in this equation or this, I will get tension in the string. And if I do this, I will get tension. I think it is twice m1 m2 into m1 plus m2 into g. If I put the value of a here, I will get tension this much. Otherwise, if I put the same value here, then also I will get the same tension. So this is one conventional method to find the acceleration and tension. Now, suppose if I apply the same method here, this becomes little lengthy, right? I will show you the method to find acceleration of each block in both the way, right? One is conventional and one is little tricky way, right? Let's work out how can we proceed, right? So for that, what I am doing, suppose I will dub this. The tension is twice. We have to remember the tension 2 mm 2 by mm. Here what? This is the tension. This is the tension. As the pulley is massless, doesn't matter. As the pulley is rest, so whatever the force pulling the pulley downward, that much the same force must pull the pulley upward also. So 2t force is pulling the pulley downward. That means the upward force must be equal to 2t. That force I have considered as t dash, and the value of t dash is equal to 2. P dash is the what? Tension in this. Now, is in any way can we replace this whole system in a single block? Can we replace this whole system into a single block? If it is possible to replace this whole system into single block, then what should be the mass of the single block? So what is the parameter I am taking here to convert this system into the system? That is the tension in the spring. Suppose if I consider this as a single block, single system, so what the system is creating tension in the spring, that is twice. Okay. So the same tension to create in this string also, what should be the tension here? But what is T? This is T. So what should be the tension here? What should be the tension here? Twice T. What is T? This much. So what will be the tension? 2 into T. 2 into 2, that is 4 M1 M2 by M1 plus M2 into G. Right? So if I replace this whole system into a single system, then the single system, this whole system to be the single system, the tension in the string should be same here and here. Right? In fact, generally, what should be the tension here? This much should be the tension. Then only we can replace this system into this system. But in general, what should be the tension here? Suppose the block, I don't know what should be the mass of this block. To consider this block as the equivalent system of this system. Suppose the mass is M equivalent I am considering. So what force it will experience by the earth, that will be M equivalent into G. So what should be the counter tension here? To balance this, let this tension T dash. What should be the tension? The tension should be, the tension here should be equal to T dash must be equal to M equivalent into G. M equivalent to G. That means, so this, the alone M equivalent is creating T dash is equal to M equivalent to G tension. Right? And here also, here the tension and the tension here also to be same, what is the tension here? This much. And what this mass is creating tension? This much. If this mass to be considered as equivalent of this whole system, like M equivalent must be, just compare these two equations. Right? The tension T dash here and here to be same, the M equivalent must be equal to 4M1 M2 by M1 plus M2. This is a simple thing we are going to apply to deal with such problem. Okay, so what conclusion I have came? I came is what? This whole system, the two block system can be assumed to be a single block system, but the single block must have the mass this much. So this system is very similar to this system. Now let's see how can we apply this idea to solve this problem. Actually, this is the problem I have taken from H.C. Verma, the famous book. Everybody goes through it for IIT preparation and even for NEET also. Now I want to find the acceleration of this block. So how can I'm going a tricky method. In a tricky method. So suppose this is the system. Suppose that I am assuming here the tension is T, here the tension is P, here the tension should be T by 2, here also the tension should be T by 2 because this is massless. So here the tension, both the tensions must be equal to, both the forces acting on the string should be equal to force on the string. Right. So what? We can see, suppose if in any way, if we can assume this two block system as a single block. If in any way, if we can assume two block system as a single block system, this will become simple application. And in that case, it becomes very simple to find the acceleration of this block. So if I replace this two block system as a single block system, the mass of the system must be this much. The mass of the system should be this much. So in that case, this whole big arrangement I can replace with a single system. How? This is 1 kg mass, this is as it is. I am replacing both the blocks into single block. Then what should be the mass of the block? This much. So what will be the M equivalent in this case? M1 is 2 kg and M2 is 3 kg. So 2 into 3, 6. 6 into 4, 24 by 24 by 5. This is the equivalent mass. So I can replace this whole system with 24 by 5 kg block. Now it becomes very simple to find the acceleration of this block. Right? So suppose this is going upward with an acceleration and the string is inextensible. This also must go down with the same acceleration. Suppose the tension in the string is T, here is also T. So it is going upward. So the forces, different forces acting on this block. Apart from T, it will also experience 1 kg, 1 g. And the mass of the block is 1 and mg. M is 1 and g. You see here also how much force it will experience? 24 by 5 g. Right. So as this is bigger one, so this will go down and this will go up. If I write the equation for this, 24 by 5 g minus t is equal to mass of this is 24 by 5 into a, and equation for this will be what simply t minus g is equal to 1, mass is 1 into acceleration is a. If I solve this, minus t plus t get cancelled, 24 by 5 plus 1 that will be 29 by 5. Here it will be 24 by g minus g, 24 by 5g minus g, that will be 19g. It will be 19g by 5, and this will be 29a by 5. So 5 gets cancelled. The acceleration is simply 19g by 29. This is the acceleration of this block. Okay. This is the method to solve the acceleration of this block in a little tricky way we now proceed. So general, how will be the conventional method to solve this question? Let's try to understand. It will be little lengthier, so we need to approach the conventional method. How will be the method? Let's try to understand. So in this problem, the acceleration of this block is a again, a1, let's assume. So this pulley also goes down with the same acceleration a1, and I am assuming this block is going downward. I am assuming, me not my assumption, be right. So I am assuming this acceleration of this block is 2, a2, that is downward, and acceleration of this block is a3, that is also downward, and this block is going downward with an acceleration a1. So let's the velocity of this is v1, velocity of this is v2, and velocity of this is v3. To proceed this problem, I should know the relation between accelerations. All the blocks will not move with the same acceleration with respect to the ground. So first of all, I need to find the relationship between the acceleration. So how will be the relationship? For that, we have a little tricky method to find the acceleration of all this block. That is the power. Power generally is the dot product of force and velocity. The power delivered by the tension, the summation of power delivered by the tension on the overall system is always 0, right? So here, if I check what is the power here, the velocity is upward, tension is upward. What is the power delivered by the tension? dV1 into cos 0 is 1. Here, the tension is upward, the velocity is downward. Only I am taking the power of the tension. Don't consider, don't bring in between the gravity. Only tension. So power of the tension here T by 2 upward, and velocity is downward, that is v2, and as the angle is 180, angle between T by 2 and the velocity is 180, that's why cos 180 is minus 1. I'm writing here in the same, in this case also T by 2 upward and velocity is downward, and as angle is what 180, that's why cos 180, that is minus 1. The total power should be 0, and if I solve this, it will be v1 is equal to v2 plus v3 by 2. So if I differentiate this, it will give acceleration, that is, this is the relation between accelerations. Okay, this is at first we have only reached to the what till to find the relationship between the acceleration. To find the actual values of the acceleration, we need to write the equation of Newton's law of motion. Right? For this, what are the different forces are acting? One is tension, one is mg, 1g. On this, one is t by 2, one is what 2g, and on this upward direction t by 2 and downward direction 3g. So if I write the equation for this equation will be simply P minus 1 into G should be equal to 1 into A1. This is equation number 2. For this ferrite, 2G downward P by 2 upward, that should be equal to T into A2. This is equation number 3. For this 3G downward P by 2 upward, this should be equal to 3 into G. This is equation 4. So here we have 4 equations, and luckily we also have 3 unknowns. 1, 2, 3 and 4. Only 3 unknowns. Sorry, 4 unknowns. We have 4 unknowns and 4 equations. So to find 4 unknowns, 4 equations are more than sufficient. So we can, by solving this all simultaneous equation, we can find the values of acceleration of each block, tension in each string. But this is what a little conventional method. So it becomes little lengthy to apply this. Right? So we can solve this problem in 2 methods. One is little tricky and one is what? Little conventional general method, generally we follow. Right. Let's apply the tricky method. Lastly, this question we are going to do. This question consists of infinite number of pulley blocks. Identical pulleys. All the pulleys are identical. All the blocks are identical. All the pulleys are light. All the strings are massless, inextensible, and nowhere friction is involved. These are assumptions we are making. Under this assumption, so this is infinite number of pulleys are there. So here we cannot apply the conventional method. Otherwise, we have to write infinite number of equations. So it do not become feasible to apply conventional method. So we go little tricky way. So how can we solve this problem? Right. This can be solved within 1 minute. So how can we proceed this question? Let's try to understand the technique what I have discussed with you. Suppose the acceleration, our aim is to find the acceleration of this block, right? The acceleration of this blocks, I am assuming something A. The acceleration of this block, I am assuming something A. Okay. So what if it is possible in some way to find the equivalent of this? To find the equivalent of this, what should be the equivalent mass of the system? If it is possible to find some equivalent mass of this whole arrangement, then what would be the equivalent mass? I don't know, right? So for that, what I am assuming, the equivalent mass of this whole system would be something x. I don't know what is the equivalent, but I can replace this whole arrangement with a block of mass x. So now one more thing is what? If this is a point, if I see below this point, how is the system? Below this point, the system is same. From this point, below this point, the system is what? Elongated T, what last scale infinite pulleys consist. This system consists of infinite pulleys. Below this point also, the same arrangement is there. That means what? If the mass of this whole arrangement is x, then mass of this whole arrangement also must be x only. Right? If the mass below this point is x, then mass of this point also must be x. So what I am doing now, I am replacing all the blocks. I am replacing all this infinite block system, pulley block system, with a single block mass x. Okay, x, and I don't know x. I need to find this x, and luckily, if the equivalent mass below this point also, if there were this whole system present, equivalent mass below this point also should be x, right? Should be x. And we have already discussed if there are 2 blocks, if there are what, this is what adult machine, if there are 2 blocks like this, then equivalent mass of this system should be equal to 4mx by m plus x. We have already did 4m1 into by 1 plus m, right? Right. So but luckily the resultant of this also should be x. That means this result also must be equal to x. Very simple. To find the value of x, this x and this x get cancelled. So remains 4m here and here m plus x. The x is what? 3m. Luckily, what? The problem becomes very simple. The whole infinite pulley block system is just replaced by a 3m mass, just a 3m. Now it's what? One fingertip. We can solve the acceleration of each block. The tension here is supposed to be, here is also T. The force is here mg and the force is here is 3mg. Now to find the acceleration of this block, how can you proceed? So here for this will definitely go down, this will go up because the mass of this is 3m, mass of this is m. So acceleration is what? 3mg minus t should be equal to 3m into a, and acceleration of this should be t minus mg should be equal to m into a. Now plus t minus t gets cancelled here. 3mg minus mg is 2mg. This is 4ma. Acceleration should be g by 2. So in this infinite pulley block system, if there were what infinite pulley blocks, this block will travel. This block will travel upward direction with an acceleration of g by 2. So this is the simple techniques we have applied to solve such complicated problems. Thank you.